In Moovie Mooving, Bessie is at a movie theater. She wants to continuously watch movies from time 0 to L. There are going to be N movies playing, each one with multiple different showtimes given in the input. We want to give the minimum number of movies that Bessie needs to see in order to watch movies continuously from 0 to L. Let's go look at the algorithm for this question. We're going to solve this question using a bitmask DP. In our state, we're going to store I, which is going to be a representation of the movies we've already watched. So if I is in binary 0, 1, 0, 1, 1, then we can take it to mean that we've already watched the movies 0, movie 1, and movie 3. So we're going to store the movies we've already watched using our state. We're also going to store two values, the last movie and the showtime. And the reason we're going to do that is in order to faster run our program, we're actually going to pre-calculate values afterwards. So in our transition, we're actually going to loop through all values of I, so all values in the state from 0 to 2 to the power of n. And then we're also going to loop through all of the movies from 0 to n. And in order to make our program faster, the way this transition works is we're going to assume in our state that for DPI, we're going to find the largest possible time we can already watch movies so that there are no gaps from 0 to that time. And we can find this value out by realizing that if I walk into a movie and Bessie decides to watch it, then we're not going to leave that movie. Since if I were to walk into a movie and then leave halfway and then continue, well, that's one more movie that I could have avoided watching. So if I walk into a movie theater and watch a movie, I'm going to watch until the very end. And so knowing that, we can find the current time, or the maximum possible time we can reach with no gaps, as the showtime of this movie plus the duration of the movie, since that's just going to be the end of that showing. And once we know that current time, for every new movie J, we're actually going to find whichever showing of J is most optimal in order for us to watch. And what that basically means is if we can find a showing of J so that in this current time there are no gaps and we can continue watching that movie, we're going to use that showing. So this isn't going to work because the end time is before the end of the current time. This one isn't going to work either because there is a gap here. So what we're going to do is we're actually going to find the showtime where the end is after the current time and the front is before or equal to the current time. And in order to optimize this, we're also going to pre-calculate values. So the reason that we store the last movie and the showtime is because now with any two movies, we can pre-calculate which movie to watch. So what we can actually notice is for any end time here, we actually, before we start, we already know what these times are going to be. And the reason is because we already know what showtimes there are, and we know all of the showtimes for all of the movies. So what we can actually do to optimize our time, normally for every end here, we would have to binary search on the value of J and the showtimes in order to find whichever showing to watch. But now we can actually pre-calculate this. And we're going to create an array called findV with 3 dimensions. It's going to be I, the last movie we watched, J, the next movie we want to watch, and then II, which is going to be the showing of I. And so once we pre-calculate every value in findV, when we reach this, all we have to do is check our findV in order to find whichever showing of J or -1 if there is no showing. So at the end, what we'll basically do is if the time or the time found, which is again showtime plus duration, is greater than or equal to the value of L, Then we'll create a value, we'll check I, and then if that value or the number of movies in I is less than the current answer, then we'll make it our current answer. So every time we update a state, we'll consistently check to see if the current time we can watch from 0 to the best time we can is greater than equal to L, then that means this is a valid showing, so Bessie can stay from 0 all the way to L. And then we'll use that value to check to see if the current number of movies we've watched is a valid answer. Let's go look at the code for this question. We have a couple data structures for this program. Our input is going to be read into schedule, which is going to contain a vector containing the movie index with the show times, and then D, which is going to represent the duration of every movie, and then the find V I mentioned earlier is going to be next show, which is a better name since it basically is going to tell us the next show. We're also going to have our DP, which again is going to be a one-dimensional DP storing a pair of integers. We're going to resize everything and read in the input. Again, we're going to have the movies be pushed into schedule, and then the duration be put into D. After we read in the input, we're going to do pre-calculating. We're going to loop through every I and J, where I and J are going to be movies, and then first we're going to check if they're the same. If so, we're not going to have two movies back to back since we can't repeat movies, so we'll just continue. And then we're going to loop through every showtime for I, and for every showtime to I, we're going to have next show IJ, and then we're going to push back the value of the showtime of J, where we are looking at the II's showtime of I. So the next possible showtime using J, assuming that our current showtime is shown with II. Our function find showtime is going to take in two values. We're going to have the time, so that's going to be the start time plus the duration, and then the movie. So we're going to do this by using a binary search, and this is just going to go through schedule M, and then we're going to first check to see if this value is the beginning, which means all values are greater, and if all start times are greater than the current time, we're going to have a gap if we use any of them. So we'll just return -1. Otherwise, we're going to set the value of start to IT minus 1, or the 1 before the upper bound, so the first value smaller than our current time, smaller or equal to, and then we're going to check to see if it fulfills the requirements. If it doesn't, which means the end time is either less than the current time or the start time is greater than the current time, as an extra precaution, we'll return -1. Otherwise, we'll return the index of this current showtime. And that's all we need for pre-calculating. So we're going to start on the actual DP. So for this, we're going to, again, have our state be the one-dimensional value, and then it's going to store the last movie, and then the schedule index. So the size is going to be 2 to the power of n, and then everything will be initialized to -1, -1. Our answer is going to start as n plus 1, so we know whether or not it's -1, meaning at the very end, we'll just print the answer checking if it's n plus 1, and since this is only possible if we didn't modify answer, that'll be -1, otherwise we'll output answer. So we're going to go through the different loops. Our first loop is going to go through I, so it's going to go through 0 to 2 to the power of n, and for every subset, we're going to check to see if it's valid, and if it is a valid subset, meaning it currently has valid values that aren't -1, we're going to loop through every movie. So we're going to first check to see if it's already been watched, and for this, since we are using bit operations, I'm going to have a couple bit operations. So we're going to have PCT, set bit, and get bit. And then over here, we're going to check to see, we're going to use get bit, which is basically going to tell us if this current bit has a value or is 1, meaning if it's already in the subset. And if it's not already in the subset, then we can continue. We're going to get our new subset by using set bit, and that's just going to set the bit in I of J to 1, and then we're going to find the value. So we need to find the last movie schedule index. And the way we're going to do that is we're going to have a corner case where we check to see if I is 0. And that's just because we set dp0 to the value 0, 0, but the value 0, 0 as in the starting index, and the value 0, 0 as in an actual possibility of 0 being the last movie we watched and 0 being the index in the last movie are two different scenarios. So this is kind of a corner case where we're just going to check to see if I is 0, and if so, we know that these values aren't really valid. So all we have to do is, since the schedule values are in order of least to greatest, we'll just check if the smallest value is equal to 0, meaning if there is a show time that starts with 0. And if so, then we're just going to have the time be 0 or the index be 0. And then if not, that means -1 or invalid. Otherwise, we'll assume we already have watched some movies, so we'll just use our next show, which we initialized earlier, and then we'll create the values using dpi.first, so the last movie, j, our new movie, and then the index of our last movie. After that, we're going to check to see if x is equal to -1, meaning is this a valid range? And if so, then we're just going to find the subset including j, and then we're going to check a couple things. If this current value of x, so our current schedule, we're going to check to see if the previous time, so using dp subset.first, dp subset.second, this is the time in the schedule subset versus our new time, which is going to be schedule jx plus dj. And if this value is greater than the original value, we'll just replace the value in dp subset. Otherwise, we won't do anything. After that, we're going to check to see whether or not this value is greater than or equal to L. So whether or not the end time is greater than or equal to L. And if it is, then the answer, this is a valid range, so the answer is just going to be the minimum of itself and the amount of movies we watched. And we're going to use that and find that by using PCT. At the very end, we've already written our output code, so that's the end of our program.